So the past 2 days we talked about the negative exponent rule. And the negative exponent rule really just states when you move a base with negative exponents across the fraction bar, negative exponents become positive. So we'll look at that rule in those two examples below. So once again, we're dealing with a negative exponent here, so 5 to the negative second power. Now I always want to write my final answer in simplest form with positive exponents. So if we're following that rule, what it's going to tell us is move that base of 5 being raised to the negative second power across the fraction bar. Now when I do that, I'm going to be left with 1 over 5, and when I move that 5 across the fraction bar, my exponent changed signs. Now it becomes a positive 2. We could simplify this a little further. 1 over 5 squared would be 1/25. So simplest form, we end up with 1/25. Notice once again, to make that negative exponent positive, we moved it across the fraction bar, and the exponent changed signs. Now for that second example, we can apply a similar logic. Notice here we have a base with a negative exponent in our denominator. Well, it's the same logic. To change the signs of an exponent, to go from a negative exponent to a positive exponent, we move our base that's being raised to a negative exponent across our fraction bar. So in this case, I'm going to take that x to the negative third and I'm going to move it into my numerator. When I do that, I'm going to be left with x, and once again, our exponent's going to change signs to the positive third power. And that's simplest form there. So that's the negative exponent rule in action. Now we're going to look at 4 examples below where we're actually applying multiple rules. So we're going to see that we're applying 2, potentially more rules to kind of simplify these expressions. So I'm going to start off and I'm going to look at this first problem on that top left. So we have x to the negative fifth times x to the positive third. Now a couple ways to solve this here, and we'll look at 2 ways we can solve this. So starting off, you might look and you might say, well, I notice a couple of things that are special. I notice we're multiplying the same bases, and I also notice that one of my bases has a negative exponent and one has a positive exponent. Let's look at method number 1. So let's say we start off and we look and we say, well, x to the negative fifth. Well, that really means, if we're applying the negative exponent rule, 1 over x to the fifth. So really I'm seeing this as 1 over x to the fifth times x cubed. Now if I multiply those together, I end up with x cubed over x to the fifth. And once again, all we did is we multiplied our numerators and our denominators. Now remember, we can actually write this in expanded form. And we've actually seen problems like this before. Well, x to the third over x to the fifth, if I write that in expanded form, it just means x times x times x over x times x times x times x times x. And what I can do next is I can simplify. I can divide that x on the top by that x on the bottom. X on the top by the x on the bottom. And we've done this plenty of times before, x on the top and x on the bottom. And really remember, we're left with kind of these 1s. And oftentimes we'd like to see those x's as kind of canceling out. And we're left with, notice, 2 x's on the bottom. So simplest form would just be 1 over x squared. There's another way we can approach this as well. So expanded form works, but let's say we wanted to use just the rules. Well, remember the multiplying same base rule. When you multiply the same bases, you add your exponents. So what I can do here is, notice I'm multiplying by the same base, x and x. I could add my exponents. I'm going to apply the multiplying same base rule. When I do that, well, I have this base of x, and once again, I'm going to add my exponents. Negative 5 plus 3. And we're just following that rule. Remember that rule from kind of the first week we talked about exponent rules. Negative 5 plus 3 would leave me with x to the negative second. Remember, what we're dealing with a negative exponent. Just like we did up top, to make a negative exponent positive, we move our term across the fraction bar. So what I'm going to do is I'm going to move my term across the fraction bar. When I do that, I'm going to be left with 1 over x squared. Notice we end up with the same answer, two different methods to get there. So let's look at that second problem on the top right. So we have 2 squared divided by 2 to the 4th. And once again, I'm just going to draw a little divider. There's two ways we can approach this problem. Well, we can use expanded form or we can use our exponent rules. Let's start off and use expanded form. Well, 2 squared, remember, is really just 2 times 2. So we can do 2 times 2. 2 to the 4th, remember, is really just, well, 2 times 2 times 2 times 2. So we can write that out as 2 times 2 times 2 times 2. Well, just like we did kind of in that previous problem, let's simplify. 2 on top, 2 on the bottom. A 2 on top, a 2 on the bottom. And notice we're left with just really 1 on top, and we're left with 2 2's on the bottom. 2 squared. We could simplify that a little further, 1/4. So when we use expanded form, we end up with 1/4. What's another way we can look at this? What if we just wanted to use our exponent rules? Well, remember, we're dividing same bases, a base of 2 on the top and a base of 2 on the bottom. When we divide same bases, we can subtract our exponents. So what I can do with this rule is I can actually do 2 minus 4. And it's important we write it as 2 minus 4 because what comes on top comes first, the 2, and what comes on the bottom, that exponent, comes next, minus 4. So yes, we're going to end up with a negative exponent, and we'd expect that because notice in our expanded form, we ended up with 1/4. But just be careful the way you write it. Next, 2 minus 4 is going to give us negative 2. Once again, to make a negative exponent positive, we're going to move our term across the fraction bar. We end up with 1 over 2 squared, or in other words, 1/4. Same answer, two different methods. So we'll look at those last two examples, and I'm just going to scroll up, and I'm just going to erase a little bit of our previous answers just to kind of give us some more room. So for that example on the bottom left, we have x to the negative third divided by x to the negative fourth. Now it's a very similar example as to that one we did previously. We're dividing same bases, we can subtract our exponents. I do want to look at it two different ways. So we're actually dealing with two negative exponents here, negative 3 and negative 4. Now remember the rule, to make a negative exponent positive, we move our terms across the fraction bar. Well, if I'm dealing with a negative exponent on the bottom, I would want to move that term up. And if I'm dealing with a negative exponent on the top, I'd want to move that term down. So one method I can use is, well, I can make these negative exponents positive by moving each term across the fraction bar. That would leave me with x to the positive fourth over x to the positive third. All we did is we moved our terms across the fraction bar, and exponents change signs. Well, now I can use expanded form, x times x times x times x over x times x times x. I can then kind of cancel out, x's, divide out. Notice I'm left with 1x on top, x, or we can write it as x to the first. Another method we could have used here is we could have just subtracted our exponents. X to the fourth minus 3 would give us x to the first, or just x. That's one method. And there are other methods as well. So you might say, well, what if I wanted to subtract? You are able to subtract here too. So we have same bases, bases of x. And notice where we have negative 3 and negative 4. Now it's the same rule. Well, if I'm dividing same bases, I subtract my exponents. I do have to be careful because it's negative 3 minus a negative 4. So the subtracting here could get tricky, so it might be a good idea to make those exponents positive first. But if we were to subtract, we would do negative 3 minus negative 4. Notice if I do that, I end up with x to the positive first, or just x. So another approach to this method would be to subtract. Once again, it's very important we're careful though, because once again, it's negative 3 minus a negative 4. So don't lose your negative signs. For that last one on the right, we have y to the fourth raised to the negative third power. This is the power to a power rule. Well, power to a power rule says when we're raising a power to a power, we multiply our exponents. Well, it's just 4 times negative 3. 4 times negative 3 would give me y to the negative 12th. Well, if we want to make a negative exponent positive, we'll move our term, our base with a negative exponent across the fraction bar. 1 over y to the positive 12th.